don't watch one. He'll be like, yeah, I'll watch it. And he goes,
Okay, so for today's lesson, we're going to talk about what percent of change is and also some words that are commonly used with percent of change, such as markup and discount. And then we're going to solve problems involving percent of change. I also put the standard on here. This is the Pennsylvania standard that we have to cover. Use proportional relationships to solve multi-step ratio and percent problems. We've been working on this for a long time because we've been doing a lot of different kinds of percent problems and ratio problems. Okay, so first objective is defining percent of change. Percent of change is the ratio of the change to the original. So you can see I have this ratio written at the bottom of the slide, ratio of change to original. So change over original, which means dividing change divided by original. Okay, these are the other words that you need to know. When stores sell something, they sell the item for more money than they paid for it. This is called a markup. So when they mark something up, it means maybe a store sells bicycles and they buy bicycles from a warehouse somewhere and they buy them for really cheap. Maybe they are able to buy bicycles for $50, okay? And then when they sell them in their store, they sell the bicycles for $100. So there's a $50 markup so that they can make a profit and their store can stay in business and they can pay the people who work there and all that sort of thing. Awesome?
if you want a bike, why wouldn't you just go to the warehouse and get one for 50 instead of going to the store and get one for 100?
Because those warehouses often will not sell to individual people. They only sell in quantities to dealers or to stores. So that's a good question. There are some places where you get somewhat warehouse type prices, like Sam's Club is called a warehouse, but you don't really get the same cheap prices that a grocery store would get for them. Okay, sometimes stores put something on sale for a cheaper price. This is called a discount. Or we say that it's on sale, but it's called a discount. And so we're all familiar with those. You get sales flyers in the newspaper all the time that say, you know, big sale, 25% off everything in the store, or these boots are on sale for $19.99 this week, normal price $24.99. So we commonly see this. Okay, this ratio is very important, this change over original. We're going to be using that a lot today. You can also think of this, if you wanted to write a proportion, remember when we had our percent over 100 equals part over whole. That's what this is. The change is like the part. The original is like the whole. And then we could put on this side percent over 100. So we can keep using that proportion that we've been using to find percent with our ratio for percent of change. Okay, does everyone have all this written down? Okay, let's go on to the second objective. This is where we look at some examples. This will make it a little more practical. Hillary, question?
There is no percent in that problem.
We haven't even read it yet, so just a second. Anne Marie's Designer Outlet sold blouses for $69.99 last week. A blouse is just a shirt, like a fancy kind of shirt. I don't think that term is used a whole lot anymore, but my grandma always used to call shirts blouses. Has anyone heard that term before?
Yep.
Yeah. Like the closest shirt in here to a blouse would be Mackenzie's shirt. It's not a t-shirt, you know, it's kind of a dressier shirt. My grandma would probably call that a blouse. Okay, so it's just a dressy shirt. I really need to change this. So she sold blouses for $69.99 last week. This week they are on sale for $59.99. What is the percent of change? Okay, so we're going to use this ratio, percent over 100 equals the change over the original. Now, there's a little extra step. We can't just plug these numbers in. We need to know what was the change. So what was the change in price? If we went from $69.99 to $59.99, how much did that change by? Kaylin,
10.
by $10. How did you get $10? Okay, good. So when you subtract $69.99 minus $59.99, you get $10. So that's the change. So you're subtracting the two numbers. So our change is 10. What was our original price, Mackenzie?
69.99.
Good. The original price was $69.99. And what we don't know is the percent. That's what we're finding. What is the percent of change? So that's our X over 100. Okay, so now we just solve this ratio. Someone want to solve it and raise your hand and tell me what you get. I'm going to wait till I see a few hands here. Sammy, what did you get?
14.29.
Good, 14.29, or let's just go ahead and round that to 14.3. So X equals 14.3%. Now, was that a discount or was that a markup? Jonathan, what do you think? Was that a discount or a markup?
It's a discount.
A discount, good. So we're going to circle the word discount, and we're going to say it was a discount of 14.3%. Okay, any questions about what we just did?
We're good.
Okay. We are going to look at example 2. Let's read this together. Harmon's Bicycle Shop. I'm hearing some talking. That's better. Harmon's Bicycle Shop purchases bicycles from their warehouse for $399.99. Okay, so these aren't your cheap Walmart bikes. These are the kind that, a little more expensive. They sell them in the shop for $599.99. What is the percent of change? So remember, we're going to do percent over 100 equals change over original. Okay, it's asking us for percent of change. So percent is our X. That is what we are finding. How much is the change, Jace?
99. 99.
Jace, how do you find how much it changes by if we go from one price to the other?
Subtract.
Subtract. So when we subtract $599.99 minus $399.99, what do we get?
You're gonna get 292.
Just Jace.
You can get like 299.99.
Johnny, what did you get?
200.
200. It works out to be 200, Jace. So the change is 200. Ben, what's the original? What's the original?
5.99. Wait, no. 5.99. 3.99.
$399.99. When you are trying to decide, this part is a little tricky sometimes. When you are trying to decide which is the original, it's always which one happened first. So did they buy it from the warehouse first, or did they sell it in the shop first? The answer is they sold it in the warehouse first. So
Really?
that's our original price.
My
$399.
warehouse too.
I just realized something. I did these on the wrong spot.
Okay, so answer. Mackenzie, go ahead and give it to us.
50%.
Good, we get X equals 50, so it's 50%. And Mackenzie, is that a discount or a markup?
Markup.
Markup, good, it got bigger, so that's a markup or an increase of 50%. Okay, let's look at one more. Well, actually, let me give you guys a few minutes to try this one first, and then we'll talk about it. If you do well with this one, you can go on and try example 4 as well. Okay, let's go over this. So we need to know our percent, so x over 100 equals. Brian, what's the change?
Oh, you subtract 597.96 minus 40.99.
Good. What do you get when you subtract 597.96 minus 457.96?
100.
No, you don't get 100. You have 9 minus 5 here, not 5 minus 5.
130.
Nope, 9 minus 5 is,
140.
there we go, 140. So our change is 140. Make sure you actually subtract the numbers to find the change. You can't just use one of the numbers from here. Addison, what's the original amount? Good. 597.96. Johnny, what did you get as an answer?
23.4.
23.4, excellent. So
Discount.
23.4%. And because they're selling it for a cheaper amount, that is a discount of 23.4%. Any questions about how we did this before we go through the next one together? Okay, let's look at example 4. The population of Gomertown was 1,395 people in the year 2000. In the year 2005, the population was 1,763 people. What is the percent of change? Okay, so in this problem, we have 4 numbers, not just 2 numbers. So some of them are extraneous. We don't need to use them in the problem, although they do kind of help us in deciding about the original. Johnny, which numbers are we going to use?
I'm going to use the 1,395 and 1,763.
Okay, how did you know to use those numbers and not the 2001 and 2005, or 2000 and 2005?
Because they're not around 6 people or anything, they're just years.
Okay, good. We want to know the percent of change, which is the percent of how much did the population change. We don't want to know how much the years changed by, so we're going to use the population. Okay, so our ratio for this, again, when we're finding percent of change, x is always over 100 because we're finding percent. What number am I going to have on top here? Volunteer, what number is the change? Anyone do this? Johnny?
That would be 368.
368, good. When you take 1,763 and you subtract 1,395, you get 368. Johnny, which number did you use as your original?
1,395.
Good. Remember, we want the one that comes first. It was 1,395 in the year 2000, which came before the year 2005. Okay, what did you get as an answer?
26.4.
Good, 26.4%.
And that was an increase.
Increase, good.
Just like, did you get it from one?
Probably.
Okay, any questions about this example? So questions about homework are inappropriate at this point. Are there any questions about this example? Mackenzie? If it's getting smaller, it's a discount. If the change went from a bigger number to a smaller number, it's a discount. If it went up, then it's a markup. So markup goes with increase, and a discount is a decrease.
So how do we know if which one goes first?
Well, in this case, it tells us that there were this many people in the year 2000, and the year 2000 happened before the year 2005. Usually it's the one that appears first in the problem. Okay, those are excellent questions. Any other questions?